We're going to look now at the real application of matrices, or at least one application of them, where they can help us solve systems of linear equations. I mentioned this when we first began taking a look at matrices. So again, I've mentioned this, but we're going to begin by adding one little twist to it. We're going to turn a matrix into something called an augmented matrix, and all that means is that it also includes a column, which is the solution to the system of equations. So let me see if they showed. So we have this system here. Notice that we also have the solutions over here. Each of these equations equals some number on the right. So what an augmented matrix is going to do is it's going to just take the coefficients. I mentioned this in the beginning video. So in front of this x is a 1, in front of this x is a 2, in front of this x is a 1. Now everybody keeps their sign. Notice this is -3. So I've put all the coefficients in and I've removed the variables. Now, of course, you need these to line up right. This first column is going to be the x column, the second column is the y's, this third is the z's. Now, here's the augmented part. You put a line there, and then you put the solutions on the right side of the line. So what we've got here is literally we've replicated this system of equations, and the matrix includes the answers. Okay, so augmenting one of these is really quite simple. The only thing would be if perhaps maybe you didn't, suppose you had 3x equals 4 for the second equation, you'd have 0 y's, you'd need to know that you'd place a 0 there. But if there's no twists, so here's my matrix, which is everything on the left, and then we're going to augment it over here on the right with just the solutions. Okay, so this is just asking us to go the other way around. So we have our augmented matrix. We're going to turn it into a system of equations. So we're just going to put the add-on-rows back. This first column will be the x's, second column the y's, third is the z's. So pretty simple. So pause it if you want to try this on your own, but we're going to do 1x minus 1y is 1z equals 5. 2x minus 1y plus 3z equals 1. So now there is a 0 here, so there will be no x's there. 1y plus 1z equals -9. All right, now what we're going to do next is we're going to learn how to find the solution to the system. And the method is called Gaussian elimination, but basically it literally is all of the ideas. It is simply the elimination or the addition method that we learned previously. It's going to look like it's something different, but the truth is it really isn't. Now, I actually don't like the way the book is doing these. The typical way to do this is what we're going to try to create here is a diagonal matrix where what's going down the line is a diagonal of 1's, and everything else has turned into a 0. So we're going to follow a series of steps, and again, it really is just the elimination method we've already been doing. But we're going to create this diagonal of 1's with everything else being 0's. And what we're basically going to do is the elimination method over and over and over again until we create this. Now, if you have an augmented matrix, if you have this diagonal of 1's, then the augmented portion over here is this column will be the solutions. It will mean x equals whatever you have here. Y equals this, z equals this. Okay, so they didn't... Okay, well, let me show you. They don't have it on this one, or if they do, I don't see it. Here are the tools that we have in our midst here. What we can do is we can switch any two rows. That doesn't change anything in the matrix. We can always, anytime we want, interchange two rows. We can multiply a row by anything we want. So we know that. If you multiply an equation by something, as long as you do it all the way through, you haven't changed anything. Or lastly, what you can do, and here's the powerful trick, what we can do is we can multiply a row and add it to another. So maybe I should say temporarily. So this one, if I multiply a row, I'm going to make this a permanent change. I want the entire row to just be a different thing by dividing through. Now, this last row means that I could modify a row by temporarily multiplying through and then adding it to another. Let me show you what these mean. So first of all, let's set this up as an augmented matrix. So I've just created my augmented matrix here. Now, I want this to be a diagonal of ones, right? This is what I'm looking for. So the first thing they say is, well, wait a minute, I've already got a 1 here. So let's get a 1 up there by switching rows. Remember I said our first trick is I'm allowed to switch rows. Okay, now they've jumped to the second. So here's what are possibilities. Once we have a 1, that's a really powerful tool. A 1 in a column can then allow us to get rid of another number. So here's what I've said. Our third trick was that we could multiply a row temporarily by anything we want and then add it to another row. What would happen if I multiplied this row by -2 and then added it here? Do you see that that would allow me to create a 0 down here? So let me show you what we're doing. We've multiplied -2 times row 1. Now it's temporary. We didn't really change row 1. We're going to leave it there. But I multiplied that through by -2. So let me show you, what do we have here? Well, I guess it's here. So it would become -2, +2, -1. Do you see? I've just multiplied that first row through. Now we're going to take that and we're going to add it to row 2. So hold on, what do we got here? -2, 2, -1. Okay, so this is my temporary change. I'm running a -2 through this top one, and I've created this. Now let's add this to the bottom row. What it would create is a 0, a 5, and a 5. I've just added them. Do you see? That's what we've done. So we saw that if I ran a -2 through here and added it to the bottom row, it would create a 0. Now I'm not done, but it's gotten me one step closer to the final solution. I now have a 1 and a 0. Now what I need to do next is turn this, we're going to work our way around the matrix. So the next thing I need is to create another 1. You always want to work on, so create a 1, make zeros. Create a 1, make zeros. So if we're here with this matrix now, my second tool is that I can multiply this through by anything I want and permanently change it. Well, let's do 1/5. If I multiplied a 1/5 through here, do you see I'd still get 0, I'd get 1, and I'd get 1. So I have it. I've got it done. So I've got a 1, I've got a 0, and I've got a 1. Now the book here takes this and turns this into a system of equations at this point. I don't like that. The typical way a calculator would do this, and I'll show you how to do that later too, but the typical way that it would be to take this all the way down to the end. So we're going to take this one step further. So we want the 1s and the 0s. So what could we do? Well, I could actually just take row 2. I don't even need to multiply it by anything. I could just take row 2 and add it to row 1. Now this isn't going to change row 2, it's just a temporary move. I'm going to take this and add it to row 1. And you see, because this is 0 here, that's not going to hurt anything. 0 plus 1 is 1. 1 plus -1 is 0. 1 plus 1/2 is 3/2. And now we didn't change this row, we just temporarily used it. So here I go. This is the finished form, and I have x equals 3/2. Y is 1. How do I know that? Because this is the x column, there's only this x equals this. This is the y column, there's only this y, it equals this. So here's my solution. Okay, let's try another one here. So I'm going to first augment my matrix. Okay, so here's my augmented matrix. This is a system of equations. So let's get the 1. So I'm going to first change. I'm going to interchange row 2 and row 1. So I'm going to make this 1, -3, -1, 4, 3, 11. So why did I do that? Because I wanted the 1 here. Remember, I'm trying to make the diagonal of 1s. Okay, now once you've created the 1, that's your key to be able to create a 0 in this column. So I'm going to take row 1, going to multiply it by -4. Okay, So I'm going to do that under here. So 1 times, or negative 4 times 1 is negative 4. Negative 4 times negative 3 is 12. Negative 4 times negative 1 is 4. So this is just temporary. Negative 1, or negative 4 times row 1, and I'm going to add it to row 2. Okay, so now row 1 didn't change. That was just a temporary thing that we did to modify it. Now putting these together, I get 0, I get 15, and I get 15. Okay, now we're halfway there. I've got a column with a 1 and a 0. But now I need this to be a 1. Here's my next one. You work your way around, get a 1 in a column, clean out the rest of the row. Or a 1 in a column, clean out the rest of the column. Now, let's make this a 1. Well, to do that, it's pretty easy. I'm going to use my second tool, which is I'm going to multiply row 2 by 1/15. That will make this a 1. So I'm going to go up here just for space. Now the first one hasn't changed. But if I multiply this row by 1/15, do you see I get 1 and 1? Okay, now we're almost there. Now the book will do this as a system of equations here at this point. I don't like that. We're going to make this 1s and 0s. So now that I have a 1 here, I can easily do this. I'm going to do 3 times row 2, and I'm going to add it to row 1. So if I make that change, row 2 isn't going to change at all. Whoops. Sorry, I screwed this up. Row 2 isn't going to change. Now 3 times row 2, I'm going to write it up here. That's going to be 0. 3 times 0 is 0. 3 times 1 is 3. 3 times 1 is 3. So here's my temporary change, and I'm adding it to this top row. That will get me 1, 0, and 2. And I've done it. I've got, so the augmented side, we don't want 1s or 0s. We want to turn this into that diagonal of 1s, and the rest is 0s. So x is 2, because that's the x column. Y is 1, because that's the y column. There's only one x left, and it must be 2. There's only one y left, and it equals 1. Okay, so here's just another one here. I'll just talk you through theirs. So 2, 4, 1, 2, we've augmented it here. Now, yeah, so to create a 1, so they wanted a 1 here. Switching rows didn't really do anything, so that tool wasn't helpful. But they immediately ran a 1/2 through here, which created the 1 we need. Now that we have a 1, we can make this a 0. That's our next goal. If I multiply a -4 temporarily through row 1 and add it to row 2, I'll have the 0 that I'm looking for. Okay, now something happened here. I'm glad I forgot about mentioning this. So look what occurred here. What happens is this row has now become empty. And what we're left with is essentially this is saying 0 equals 4. Do you see why? There's nothing left. There are no variables left, so I have 0 equals 4. Well, we've learned before that isn't true. So this is impossible. There is no solution. So here's what this means in our previous language. This is just a system of lines, and it means this is a new approach to trying to find where they intersect. And what this is saying is they don't intersect, and so there is no solution. So if we actually took a look at this, we'd find they're parallel lines with a different y-intercept. So they don't hit, so that's why there's no solution. So again, the x's and y's fell out of this row, and all that was left was 0 equals 4, and that's not true. Okay, so let's augment this. Yeah, okay, so we're going to just jump ahead. It's all the same process here. So if I were looking at, I've augmented this, I want this to become a 1. I'm trying to look at what they've done here. Well, I'm not sure why they did it the way they did it. I wouldn't have done it that way, but it doesn't matter. Their way is faster. But let's just see what they jumped to. They found a way to combine these, and what they got left, they have a row where 0s equal 0. Now, your calculator or something else would typically put this on the bottom. So don't worry about so much how they got here. They did it in a different order than we would have discussed, but you're going to get here no matter how you do it. And what you're left with is 0 equals 0. Well, that's true, right? We've seen this where 0 equals 0. That is true. And so what is happening here is that these must be the same line. They're touching everywhere, and so you have an infinite number of solutions. Okay, so that'll get you started on augmented matrices and using Gaussian elimination. Again, your tools are you can switch rows, you can multiply through a row, or 3, you could temporarily multiply a row and add it to another row. So those are our 3 tools, and what we're trying to create is that matrix with nothing but 1s down the diagonal and 0s everywhere else. And except, don't forget, of course, the augmented side, the solution side of the matrix, is going to tell us the answers that we have when there's nothing left but those 1s.